Welcome to the UNCC Viscus Senior Design Expo poster presentation. The poster is divided into 10 sections. First is the project background, intro and objective, platform specifications, subsystems, and significance of rod diameter to the project. Future plans and references of the project will also be discussed.
The current project uses reinforcement learning to transport particles from one arbitrary position to another. Particle manipulation science attempts to skillfully control minute portions of matter by removal, transportation, or separation.
The UNCC Viscus team's objective is to develop a reusable laboratory platform that uses vibrating centimeter-scale rods and a viscous fluid to manipulate particles. The vibrating rods will induce a streaming flow with a Reynolds number on the order of 10. A camera will be used to log movements of particles for the end goal of reinforcement learning.
The laboratory platform was built with a budget of about $1,000. The platform uses cylinders for the vibrating rods. The Raspberry Pi 2 camera is used for particle position logging for reinforcement learning.
5 identifiable project subsystems are the fluid container, container support structure, container cover and device support, vibration device, and the electrical control system. The current project system fluid mechanics, which are based on the rod diameter, are driven by equations from the previous study. Figure 4 shows a fluid container featuring a release valve for reusability. The transparent acrylic container panes prevent the outward flow of canola oil. The container dimensions are 58 by 27.8 by 15 centimeters, able to hold 8 vibration devices on top.
The container support structure consists of 4 welded L-beams preventing the platform from collapsing. The columns are included to raise the platform 30 centimeters high for the Raspberry Pi camera. The Euler buckling formula was used for a proper column design.
The container will be covered by what the team calls the zigzag plate. It has serrations and slots so that the vibrating rods can be secured and positioned with a precision of 161.4 millimeters along the x-axis and 9 millimeters along the y-axis.
The vibration device can change the oscillation frequency and oscillation amplitude. By adjusting the frequency, it would change the Reynolds number. To create linear vibration, the team would be using the Pololu 19-to-1 metal gear motor. To change the axis of vibrations, the team would be using an XSR-1425CR servo motor with a pinion to drive an 84-tooth gear. 8 total roller bearings on the side and bottom help rotate the inner casing smoothly.
We are using 120 volts AC from a wall outlet and converting it to 12 volts DC for the motors. We are then stepping down the 12 volts DC to 5 volts DC for all logic level electronics. The estimated amperage should be around 440 milliamps.
The team plans to have a tested prototype for the particle manipulation platform by February 1st, 2021.
The project references are shown here. This concludes the poster presentation. Thank you for listening.